Welcome back to Max with RP. Today we are going to solve multiple choice questions based on the chapter of relations, in particular equivalence relations, and also on the topic inverse trigonometric functions. Let's look at the problems that we have. First one, the domain of the function sine inverse root of x minus 1 is. So we will write let sine inverse root of x minus 1 be equal to theta. Then root of x minus 1 equal to sine theta. See, sine theta lies between minus 1 to plus 1. So minus 1 less than or equal to sine theta less than or equal to 1. However, in this case, sine theta is equal to root of x minus 1. You know that square root is always a positive quantity. So 0 less than or equal to root of x minus 1 less than or equal to 1. Which on squaring gives you 0 less than or equal to x minus 1 less than or equal to 1. 0 less than or 0 plus 1. So 1 less than or equal to x less than or equal to 2. So the correct answer is 1 less than or equal to x less than or equal to 2, which we can write as a closed interval 1 comma 2. Now let us look at the second problem. The domain of the function sine inverse x square minus 4. So we can write sine inverse x square minus 4 as theta. So sine theta equal to x square minus 4. Sine theta lies between minus 1 to plus 1. So minus 1 less than or equal to x square minus 4 less than or equal to 1. So minus 1 plus 4 less than or equal to x square less than or equal to 5. So 3 less than or equal to x square less than or equal to 5. One possibility we can have x 3 root 3 less than or equal to x less than or equal to root 5. That is case 1. The other case is minus root 5 less than or equal to x less than or equal to root 3. Minus root 3. Why? Because x square is not only the square of x, it is also the square of minus x. So when I put minus x, I will have minus x the whole square, 3 less than or equal to minus x the whole square, or root 3 less than or equal to minus x. Root 3 less than or equal to minus x is the same as x less than or equal to minus root 3. Similarly, minus x less than or equal to root 5, which is same as minus root 5 less than or equal to x. So either case 1 is possible or case 2 is possible. You are listing out when you say domain all the possibilities. So root 3, root 5 union this. So minus root 5 minus root 3 union root 3 comma root 5. So this is the right answer. Minus root 5 minus root 3 union root 3 comma root 5. So are you able to understand how to find the domain of such inverse trigonometric functions? Next, we are going to find the principal value. The first question is sine inverse of sine of minus 10 pi by 3. You have to find the principal value. Okay. Now, this is sine inverse equal to sine of minus theta is minus sine theta. So, I am going to put the minus here, 10 pi by 3. Which is, how can you write 10 pi by 3? I can write it as 3 pi plus pi by 3. So I am going to write it as, and sine inverse of minus sine theta is minus, I can take this minus outside. So I will get minus sine inverse of sine of 3 pi plus pi by 3. Which is further minus sine inverse of sine of, what is 3 pi plus pi by 3? So 2 pi you complete one full circle. So when you are completing 3 pi, then you complete one full circle and one other half circle. So that will take you to the third quadrant. In the third quadrant, sign is negative, so it will give you minus pi by 3. So now sign of minus pi by 3 is again minus sine pi by 3, which again brought outside will give you sine inverse of sine of pi by 3. Which is equal to pi by 3. Next question, this is the third one. What is the principal value of sine inverse cos of 43 pi by 5? Now, this is equal to sine inverse of cos of, how can I write 43 pi by 5? I can write 8 times 8 5s of 40, so 8 pi plus 3 pi by 5. So it goes on 4 rounds. 2 pi is 360 degrees, so 1 round. So 8 pi is 4 rounds and it comes to the first quadrant. So this is sine inverse of cos of 3 pi by 5. This is sine inverse of cos theta can be written as sine of pi by 2 minus theta. Pi by 2 minus 3 pi by 5. What is pi by 2 minus 3 pi by 5? Pi by 2 minus 3 pi by 5 will be 5 pi minus 6 pi, which is minus pi by 10. So this is minus pi by 10. Sine inverse of sinus will give you the same output, which is minus pi by 10. So minus pi by 10 is the correct answer. So this is the principal value of sine inverse cos of 43 pi by 5. Is it clear? Now, for sine inverse x plus cos inverse x is pi, you have to find the value of x. So for sine inverse x plus cos inverse x equal to pi. I can write this as 3 sine inverse x plus 1 sine inverse x will combine with cos inverse x to give you pi by 2. So 3 times sine inverse x is equal to pi by 2. So sine inverse x equal to pi by 6, or x is equal to sine pi by 6. Sine pi by 6 is sine 30, which is half. So half is the correct answer. What is the sixth problem? A is a 3 by 3 matrix such that determinant of A equal to minus 2. You have to find the determinant of minus 2 A inverse. So if you look at the matrix minus 2 A inverse, and for that you are looking at the determinant value, then I will take minus 2 from each row. So this will give me minus 2 cube into determinant of A inverse. We know that A inverse is I. So A inverse determinant of A into determinant of A inverse is 1. So determinant of A inverse is 1 by determinant of A. So this is minus 2 cube into 1 by determinant of A, which is minus 2 cube into 1 by, what is determinant of A? Is minus 2. So 1 minus 2 gets cancelled, giving you minus 2 square, which is 4. Is it clear? So the property that we have used here is determinant of AB is determinant of A into determinant of B. And when you look at the matrix minus 2A inverse and you look at the determinant value, you are going to remove minus 2 from each row, because in a matrix you multiply every element by a scalar. But in a determinant, if one row has a scalar, it can be removed from that row. So that is the difference between matrices and determinants. So from each row you can take out -2. So -2 cube into determinant of A inverse, which is 1 by determinant of A, which is 1 by -2, so which is 4. Consider the problem. A is a square matrix of order 3 such that A into adjoint of A is 10i. So we have A into adjoint of A equal to 10i. Then you have to find the value of determinant of adjoint of A. Okay. Now let us take determinant. So determinant of A into determinant of adjoint of A will be, see, this is 10i, the matrix 10i. When I convert it into determinant, I will get 10 cube into 1. And you know that determinant of adjoint of A is nothing but, we want to find the determinant of adjoint of A. So you have to know what is determinant of adjoint of A in terms of determinant of A, which is determinant of A to the power n minus 1, which is square here. Therefore, this line is equivalent to determinant of A the whole cube equal to 10 cube. So determinant of A equal to 10. But what is asked is, what is determinant of adjoint of A? Determinant of adjoint of A is 10 square, which is 100. So 100 is the correct answer. So you must understand the properties clearly well so that you can use the properties to solve the problems. Now, the number of points of discontinuity of the function, 10th question, where is the function discontinuous? Now, f of x is equal to x cube minus 3x plus 2 divided by 4x minus x cube. So, where all is the, at what points is x not defined? What will happen if the denominator is 0? So 4x minus x cube can be written as x into 4 minus x square. If I equate it to 0, then I will get x is 0 minus 2 plus 2. So for all these three values, the denominator is not defined. So at those points, or the denominator vanishes. So at those points, the function will be discontinuous. So for three values of x, the function is discontinuous at 0, minus 2 and 2. What about the number of points of discontinuity of the function f of x equal to modulus of x minus 1 plus modulus of x plus 3? Now we have f of x equal to modulus of x minus 1 plus modulus of x plus 3. So sum of two modulus functions, if you have, you all know the graph will be a trough. So x equal to 1 and x equal to minus 3. So how will the graph be? It will be something like this. So is it continuous? It is not differentiable at 1 and minus 3, but it is a continuous function. So the number of points of discontinuity is 0. However, if you are asked at how many points is the function not differentiable, then you should say it is not differentiable at 1 and minus 3 because it has got sharp corners at x equal to 1 and x equal to minus 3. Now let us look at the 12th problem. The function y equal to cot x is discontinuous. In fact, you can even ask where it is not defined. Okay. So where is it not defined? Y equal to cot x is equal to cos x by sin x. If sin x is equal to 0, then what will be the value of x? It will be odd multiples of pi by 2. So n pi by 2, where n belongs to z. So at those points, the function is not defined. Therefore, there will be a break in the graph of cot x at those points. Next, 13th question. y equal to square bracket of x. See, if you take integral values, see for example, if I take say 1, okay, what will be 1 minus, if I take if I look at a very small neighborhood around x, and let us look at limit extending to 1, okay, I want to look at limit extending to 1 of mod x, then it will be what? 1 minus, when it approaches x through values to the left of x, it will be 0, whereas limit extends to 1 plus of square bracket x will be 1, because it will be, x will be assuming values to the right of 1, so greater than 1. Here x will be assuming values to the left of 1, x is crossing, and therefore the value of the greatest integer function will be 0. For example, 0.999. What is the value of the greatest integer function? 0. Whereas 1.00001. What is the value of the greatest integer function? 1. Therefore, at integral points, at integers, square bracket of x is discontinuous. Okay. Whereas, if you take limit extends to 1.5 of square bracket x. So limit extends to 1.5 minus of square bracket x will be 1, because it will be values very close to 1.5 to the left of 1.5 in the number line. Limit extending to 1.5 plus of square bracket x will also be 1, because it is also close to 1.5 but to the right of 1.5. So in both the cases it is 1. So where is it discontinuous? It is discontinuous at integral values. So the greatest integer function is discontinuous at 2, it is discontinuous at 0, it is discontinuous at minus 3. So it is continuous only at 1.7. I hope it is clear. The derivative of the function f of x equal to x mod x at x equal to minus 2. So let us look at f of x equal to x mod x at x equal to minus 2. First let us write the definition of mod x. Mod x equal to x when x is greater than or equal to 0, equal to minus x when x is less than 0. So x mod x will be equal to x square when x is greater than or equal to 0. Then mod x is minus x. So minus x square when x is less than 0. X into mod x. So for x is positive, mod x is x, so x square. When x is negative, mod x is minus x. So minus x into x is minus x square. Right? Now, we want to check whether, find the derivative at x equal to minus 2. At x equal to minus 2, what is the function you will use? F of x equal to minus x square. So f of x equal to minus x square. So f dash of x will be minus 2x. At x equal to minus 1, f dash of x will be minus 2 into minus 1, which is 2. Okay, so the answer is 2. See, it is minus, if I differentiate, I get minus 2x. X is minus, we want to find the derivative at x equal to minus 2, sorry. Then I will get minus 2 into minus 2, which is plus 4. So the answer is 4. The function f of x equal to e power modulus of x minus 1 is continuous and differentiable everywhere, not continuous at x equal to 1 but differentiable everywhere, continuous but not differentiable at 1, continuous but not differentiable at x equal to minus 1. Several options are given. If you look at the function, you know it is the composition of two functions, namely the exponential function and the modulus function. And we know that the modulus function is not differentiable at x equal to 1, right? So, however, we know that the exponential function is a continuous function. So, This is continuous but not differentiable at x equal to 1. Continuous but not differentiable at x equal to 1. So in your mind, you should recall the graph of e power x. It passes in the first, e power x is always positive. So it will be there only in the with respect to the positive y-axis, and it is an increasing function. Now let us look at this problems. Integral of x cube by root of 1 plus x square dx. So how do we integrate this? Now I can be written as integral of, so I can write it as x square into x dx by root of 1 plus x square. Therefore, I can make use of substitution and write 1 plus x square equal to t square. So, root of 1 plus x square will be t. Now, if I differentiate this, 2x dx is 2t dt, or x dx equal to t dt. So, I will be equal to integral of, now what is x square? T square minus 1. X square is t square minus 1. X dx is t dt divided by root of t square, which is t. This is t cube by 3 minus t plus c. What is t? Root of 1 plus x square. So 1 plus x square to the power half raised to the power 3 will give you 3 by 2 by 3 minus t is what? 1 plus x square to the power half plus c. Now, what is the value of a? A is the coefficient of 1 plus x square to the power 3 by 2. So, a is 1 by 3. From here, a is the coefficient here, which is 1 by 3. B is the coefficient of root of 1 plus x square, which is minus 1. So, a is 1 by 3 and b equal to 1. So, this is the correct answer. Are you able to follow? Let's look at the next question. What is the next question? Integral of cos 2x dx by sin x plus cos x the whole square. Cos 2x, I can write it as integral of cos square x minus sin square x by cos x plus sin x the whole square. Now this is cos x minus sin x into cos x plus sin x. So 1 cos x plus sin x gets cancelled, giving you cos x minus sin x by sin x plus cos x. The derivative of sin x is cos x, the derivative of cos x is minus sin x. So this is nothing but dt by t. dt by t is log mod t plus c. So log mod sin x plus cos x plus c. So this is the correct answer. This is the value of the integral cos 2x by sin x plus cos x the whole square. So I have written cos 2x as cos square x minus sin square x, factorized, cancelled out as one common factor, and then I have used integration by substitution. In fact, this is a question right straight from your textbook, the NCERT textbook. So please be thorough with the NCERT textbook. I hope you found today's session useful. We were solving multiple choice questions from different topics. I hope you will practice a lot more problems of the same type. So until we meet next time, it's goodbye from Max with Aarti.